Sí, sí, más que todo los daños han sido en las carreteras. Ha
Claro.
habido varias viviendas colapsadas, pero tengo la impresión de que el principal daño ha sido en las carreteras.
Había harto adobe, por lo que pude ver también todavía en
Sí,
algunas
sí,
partes,
sí,
¿no?
sí,
Ah,
así es. Ujú.
muy bien. Easy, good morning.
Good morning, Florencio. How are you?
Fine, and you?
I'm good, thank you.
So you're going to be the chair of the main room when we break out the session, right?
Yes, yeah, happy to.
Perfect. You have the power also. I give you the co-host power.
Thank you.
Okay, we are. Sí. Vamos a esperar 5 minutos a que pasen los 5 minutos académicos que acostumbran a ver. Me imagino que ya la traducción está funcionando. Phil, Easy, Einar, ¿me escuchan bien en inglés, no?
Can you hear in
So
English
Phil,
what
can you
I'm
hear me in
saying
English
now?
now? I mean,
Can
is
you
that
hear
the
in
case? This
English?
is your interpreter speaking.
Oh, yeah, that's correct. That's correct, yeah.
Please use your English channel in the translation. So you-
Bueno, muy buenos días a nuestros amigos que nos acompañan de...
Good morning to everyone joining us from Latin America. Good afternoon to those who are the other side of the world from Europe. And good evening maybe to people who's in different latitudes in other continents, who has been with us before. Yesterday was a day when we had people from very far away. In case you didn't join us yesterday, let me tell you that this session will be simultaneously interpreted. That means that you can select your channel in Spanish or English in the taskbar. I also have to tell you that until the panel and the conference is being broadcast through YouTube. Once more, welcome you all to this second day of the seminar on natural disaster. You know, is part of the series of Copernicus satellite data in Chile and Latin America, building collaborative applications and network. This series has 5 seminars. The first one was climate change, and this one we are approaching now is natural disasters. This initiative is organized thanks to a collaboration funded by the Copernicus Framework Program between the Center for Mathematical Modeling University of Chile on behalf of the Copernicus Reference Center Chile and the Joint National Conservation Committee JNCC UK. Once more, I welcome you. I thank you for joining us, for finding the time to be here with us during these 2 hours. We had an excellent work yesterday, and we hope the same for today. Now I'd like to turn it over to Mr. Jaime Ortega, who will chair this session. Dr. Ortega is a professor in the Department of Mathematical Engineering and main investigator of the Center for Mathematical Modeling, and is also part of the Advanced Center for Water Technologies CAPTA from our faculty. He's a member of the University Senate at the University of Chile. Jaime has an extensive background in control theory, inverse problems, and image processing. Besides, he has extensive experience in applied projects in areas such as mining, among others. Now, I'll give the floor to Mr. Jaime Ortega. Jaime, good morning, good afternoon, good evening. Carmen Gloria, thank you very much for your presentation. Thank you very much for joining us. We're going to continue with our workshop. Today's subject matter will be hydrological risk. We have interesting speakers. The first part will be a conference. It will be a shared conference. There will be 2 speakers. It's like a 30-minute talk. Then we'll have the Q&A session. So you are welcome to feel encouraged to include your questions in the chat box of the Zoom platform. Then we'll start with the debate. It is my pleasure to introduce Esperanza Mesquita. She has more than 35 years in the field of research and development. Dr. Mesquita has worked as a scientific researcher in different organizations, mainly in fields related to soils and agriculture. In 2007, she joined Tracasa, where she has participated in numerous projects related to soil salinity, geospatial data, digital mapping, remote sensing, and GIS use. Since 2012, she participates in the map validation team of the Copernicus Emergency Management Service. It is also my pleasure to introduce Aranzazu Larayanga Urien. She has a degree in agronomic engineering and a diploma in advanced studies in rural and environment engineering. She has more than 13 years of experience in the Department of Territorial Information System of Tracasa as a technician in optical and radar remote sensing and GIS, and in the coordination of the production of digital products derived from satellite remote sensing engines. She has extensive experience in the use of optical and radar data for various applications such as disaster, flood and volcano monitoring, agricultural applications, crop classification. And since 2012, she's part of the Copernicus Emergency Management Survey map validation team. They will present about the application of the Copernicus Emergency Service in floods, early warning, use cases with Sentinel-1. The floor is yours. Good morning. Firstly, I'd like to thank you for your invitation, for having us here in this workshop. I will start by sharing my screen. Can you see my screen? Perfectly, yes.
Aquí, ¿verdad? Sí. Bueno, eso les
Now it's perfect. I was saying thank you very much for having us in this workshop. We are from Tracasa. It's a public company from Navarra in the north of Spain, cooperating in the service management service of Copernicus. I want to apologize because Asibel Goñi, the manager of this company, of this business, was going to be part of this workshop, but as last minute's notice and due to some personal reasons, she won't be able to make it here today. What we will see here is the Copernicus Emergency Service Application Early Warning. The agenda is divided in 3 parts during these 30 minutes of presentation. One very brief to see what's the management service of emergency by Copernicus. The other one, where we will see the application of the European warning system, early system, to utilize the mapping of floods in ready mapping, and that will be presented by my partner. Okay, let's start with the management service, emergency management service of Copernicus is managed by the GRC and consists of 2 components. One component of mapping, which has 3 services. One service of rapid mapping to create maps and in response to an emergency at the time of the emergency, a service of risk and recovery mapping to produce products, maps in this case, for the phases of preparation and recovery in front of disasters, and then a validation service. And here is where our company takes place. And what Tracasa does is to validate by request of GRC a selection of products generated by these 2 services. Coming from this mapping service is an early warning system for fires called EFIS, for floods that's called EFAS, and for drought it's called EDO for Europe. And then we have the corresponding in the world GWIS, GLOFUS, and G2. These mapping services, rapid mapping and risk and recovery, the objective is to facilitate use phase information to improve the information in the various phases of the emergency. And in order to have access to these services, they work on demand. To activate them first, they must be requested. And we'll see here, if you're interested, in how the countries can request these services. First, in order to request the service, you don't have to be an authorized user. In the case you are not, you will have to contact the authorized users. In the case of Europe, Authorized users are, in each country, the top authority in civil protection. But outside Europe, for example, Chile or any other country in Latin America or South America would like to request these services, they will have to contact ERCC, which is the Coordination Centers of Emergency Response of the European Union. And I'm going to leave you the email there. And in order to request these services, you need to fill out a document and say, all right, what is what we need? What type of products we will need? How are we going to use and what for we'll use these products, and when will we need that products, and in which areas of our country would like to have those services. And after that, this request is submitted to ERCC, and ERCC is to activate or not these services. And to do so, what ERCC says, okay, is this an eligible request? So they must comply with some requirements. If you want more information, that's the link you should click on, and then you will find the guide for this warning system. And if a country would like to request the activation of these services, how to choose or to select what's the services you are interested in? Well, it depends on what you need. If there was a disaster, a flood, and the country would like some products for the phases of emergency response, and that's urgent, for example, mapping for the floods in 24 hours time, they will have to select the rapid mapping service, the service levies 1 mode, which in 24-hour time will generate the first product. If that's not an urgent situation and you can wait for some time, then you might request service level 2 in rapid mapping. The rapid mapping service, in both cases, contribute, and what they can generate are 4 types of products: an estimate product, and then reference maps, damage alignment map, and classification maps. In the case you'd like to generate products for the phases of preparedness or recoveries in a disaster, then you will have to select the recovery mapping and service with 2 modes: a standard mode consisting of 20 standard products. Then, if you want a product and it is within those 20 products, then you will have to request this standard mode. In the case you like a more specific product, tailor-made product, then you should request the risk and recovery mapping flexible. And then you'll have those 2 products within 1 or 2 months. Then let's go for the second part, which is the application of the early warning European system to facilitate the mapping on floods or rapid mapping. We'll see the information that is created by EFAS, and it will work properly with the mapping service. EFAS, as I was telling you, is the European System of Early Warning for Floods, and their goals are to provide products to minimize the impact due to floods, particularly in great fluvial basins, European ones, and then to inform ERCC of the emergencies on floods. IFAS consists of 4 big centers, each one with their different consortiums: one for collecting meteorological data, hydrological data, a center, a computational data center where simulations and predictions are conducted, and a data dissemination center. And EFA also has 4 types of uses. Partners, who are the product users. Basically, the fundamental partner are those entities holding responsibilities in the risk management when we have floods. And then we have the type of products generated by EFAS. Different type of products. I'm not going to go into detail, but we will focus on one of them, which is the flood impact forecast. They contribute with information improving rapid mapping. Based on that, if they can identify areas, AOI, which is the Copernicus terminology, areas of interest, areas that possibly will be flooded. Then you can request anticipatedly for those AOIs, and that will improve rapid mapping. And on the other hand, a protocol has been created to integrate, to embed this information of IFAS in rapid mapping. And this is what we'll briefly see now in these two steps. Products generated by EAS and of interest for the mapping. Flood hazard map, based on those maps of hazard and flood, possible areas that will possibly be flooded. Risk elements are identified, whether this population that might be damaged, if there are some assets, if there's infrastructure, and so on. And then vulnerability of those elements is analyzed. Then by combining the hazard flood hazard map with the elements exposed here and the vulnerability, flood risk map are created. And from there comes the potential impact the flood will have. And based on that, and from there, the areas we may have a relevant negative impact are identified. And later it goes to rapid mapping, which has to do with affected or potentially affected areas that may have a negative, a relevant negative impact, so that an anticipated request of images can be conducted. That would be the flow or the steps to transfer that interest information created by EFAS to rapid mapping. And we'll see that now. This flow or these steps consist of 5 main steps. In the first step, when EFAS identifies or forecasts an imminent flood, what they do is to send early warnings by email, first by email and then by phone to ERCC, to their partners, and the service provider of rapid mapping, who are those who create rapid maps. So when are these early warnings sent? When the flood that is predicted or foreseen to have a medium or high impact, and it's the medium or high probability to have that flood, and what is the information to be submitted with the early warning? The foreseen moment when it is expected to have it, and when it's expected to see the duration, potentially affected areas, and then the period window for the image acquisition. And by having that information, the service provider of rapid mapping can start requesting images to ESA, which is the European Space Agency. In the second step, ESA can start obtaining images. And at the same time, ERCC informs civil protection in the country where flood is expected. They say, okay, watch here. We have had an early warning and we are already acquiring images. So you must take into account that you can't request the service mapping service. Then the service provider of rapid mapping inform everyone on how those images will be acquired. ERCC informs civil protection in the country where they will acquire those images, and they say, okay, would you like to request the rapid mapping service? In the case civil protection says yes, then I like to request service mapping, rapid mapping service. Immediately they start creating maps of alignments for the flood with the images captured here. And once they have the map, they deliver it to civil protection. In the case civil protection does not want to request rapid mapping service, then the acquisition of images will be cancelled. And in the case they would not answer anything, I'm talking about civil protection, then images are automatically stored and they are not analyzed. And what we will see here now is in a visual form the effect the early alert system has in rapid mapping, how images are requested and how are they delivered. The maps of flooded zones. When we have had a flood, if the service of rapid mapping is activated after the flood, then the request for images immediately starts. Then we start acquiring images. Images are delivered to the service provider of rapid mapping. It can take some hours. Once the service provider of rapid mapping gets the images, they start creating maps. And once they have the first map, they deliver it to civil protection. But what happens here? We have an early warning system and they have predicted this flood with anticipated time and they have sent early warnings. Once they send that early warning, images start to be requested before the flood. And then we'll see that images are requested before rapid mapping. Clearly, all the process is anticipated. The service provider of rapid mapping receives the images before rapid mapping, they generate the maps before rapid mapping, and so civil protection may have the maps of flooded zones before. There's some couple of hours to be bought there. This is due to the early warning system, crucial for these situations. This is part of my presentation. I will start sharing a screen so that my colleague tells you about the cases. Thank you very much, Esperanza. Okay, thank you very much. I will continue so that we don't have any problems.
Vale. Sí, perfecto. Bueno, pues nada, buenas tardes o buenos días a todos.
Good afternoon, everyone. So what I'm going to present are some concrete steps where we have tested the uses to monitoring floods. But before that, before we see these examples, we think it's quite interesting to mention briefly some data of the rapid mapping activation, which have been done since April 2012 up until December 2020. All of the data I'm going to present are coming from an article which was just published, which is the one I'm telling you down here. So first of all, I'm going to cover this data and then later I will show these three use cases. So first of all, this rapid mapping service has been activated 491 times between April 2012 and December 2020. And the number of activations per year has increased in the last 4 years. If we pay attention to into the first graph, we see that the event for the service was mostly activated was for flooding with a 35% and wildfires with a 25%. If we concentrate in floodings, most of them, in 69% of them, were from rivers, and out of that 69%, 61% were activated in Europe and 39% outside Europe. Talking about the type of sensors being used to obtain the flooded areas from rivers, fluvial sources, SAR data are the main ones, 76%, and the optical one, which is being used only on a 24% of the times. Most of the images, SAR images, correspond to images of high resolution, between 4 and 30 meters of resolution. So that's where Sentinel is located. So as you well know, the main advantage of these radar sensors, it is that clouds do not affect them and they can be acquired both during day and night. And this is quite interesting if we consider that these flooding events are connected to adverse meteorology with presence of clouds. So Tracasa, validating these Copernicus products, has tried this applicability of the product Sentinel in the management of emergencies. So the main goal it is to verify that the Sentinel data represent reliable data sources. And for its validation, we're going to use information of reference obtained from images of a higher spatial resolution than Sentinel. So within this context, we have seen or we have tested the usability of these images for the detection and monitoring of floodings in many different occasions. So now I'm going to present 3 cases. Each of them correspond to one different study case, and in each of them, we have used a methodology which is different in order to identify the flooded area. In the second case, we're using the multitemporal factor, and in the third one, we're using the double polarization approach of Sentinel-1. And the first one, it is an event which occurred between December 2015 and January 2016, and it was in Ireland. It was a flood quite big due to heavy rain, which lasted months in most of Ireland in a flat ground and a ground saturated with water. The method was the retrodispersion of radar coefficient. So the water have really low retrodispersion because they reflect, as we can see here, they reflect most of the radar signal which is being received. So therefore, this body of water are visible in the radar images. So here I can show you an example where we can see that the surface, the flat surfaces such as waters, here we can see the rivers, some roads, airports. I mean, they look or they are seen in black in this radar image. And in this case, this reference information was obtained from an image. Cosmos Calumet acquired the same day of the Sentinel, but with a better resolution, 5 meters, and with a polarization which was much more appropriate, HH. So here I'm showing the flow of work of this first method. So first, the image from Sentinel-1 is processed from December 13th using the free software Snap. Later, the water spot was obtained through a classification supervised at an object level using feature analysis software from Artes. Permanent water was obtained and the layer was manually retouched with some pre-event images and so on in order to eliminate some areas which cannot be flooded. So the Cosmos Calumet image acquired on the same date as the Sentinel-1 on the December the 13th was already processed. So from this processed image, we did the same as we did with Sentinel in order to obtain the delimitation of the flooded area that would be used as a reference. So in this case, the validation was centered in 3 small zones of study within the affected zone. The results indicated a good level of concordance between the data obtained through radar, with a coefficient of layer higher than 0.64 for the 3 elements. The results with Sentinel-1 were quite similar to the ones obtained with Cosmos Calumet, though Sentinel-1 has a lower resolution and a polarization, which was not so appropriate. So on the right over here, we see 2 detailed zones in the comparison done for Sentinel-1 and Cosmos Calumet. On the left, Sentinel, on the right, Cosmo. Errors of omissions are there. They're marked in green. Here we have the big zone, and here we have the details of these 2 small zones. So errors of omissions are present here, and they are in green over here, and they are due to the difference of resolution, spatial resolution, and also because of the polarization difference of images which were used, HUV against HH. That is to say, On the one side, the resolution, spatial resolution, which was not good for Sentinel-1, omits some small zones of water. But we can also see differences in terms of polarization, because we can see zones in Cosmos Climate that give a response, a presence of water, and in Sentinel-1, they're not so well, they're not easy to see, and they're confused with waters without water. This is an example here over this peak. So now we're going to see the second case. In the first case, we used the retrodispersion coefficient to identify flooded areas, because the flat surface of water have some retrodispersion values which are quite low, and they're easily visible. They're easy to see. But what happens? There are some elements or flat areas such as highways, airports, which may show a similar response to the water surfaces. That is to say, they are easy to confuse with water. So we could see that alternative way of getting information about floodings from the SAR data was by using information from coherence. Coherence between two images, SAR images, will contribute information about the stability, temporal stability of the objects on the terrain. That is to say, if they change or not. So we may use as a layer of information, additional one, when the intensity of radar itself, it is not enough to discriminate flooded areas and non-flooded areas. So in the next case, use case, had as a main goal to go one step beyond and trying the coherence data usage for the detection of floods and its monitoring. So the method MTC, multi-temporal coherence method, was applied to an event of heavy rain occurred in Peru between March and April 2017. The study zone, it is a flat area with little vegetation and with no human presence, the one we can see over here in this image. So the image MTC image comes from two Sentinel-1 images of identical characteristics, but that were acquired in different moments, in T1 and T2. That is to say, image from MTC, it is a unique image that comes from combining the coherence image and the intensity detected in T1 and 2. Sentinel images which were used were the one presented in this chart on the right, top right. 3 pairs of images were processed to estimate the flooding in 3 different dates: 23rd, 26th of March, and the 1st of April 2017. For the 2 first dates of monitoring, we did not have high-resolution images where to obtain reference information. So in these 2 cases, the delimitation of the flood was obtained by using the coefficient method of retrodispersion explained in the first example from Sentinel-1 images obtained on the 23rd and 26th of March. But for the last monitoring date, 1st of April, we had an image, optical image of 5 meters of resolution. So this slide shows the flow of workflow. So on the left, the obtention of flooded areas for the different dates of monitoring from the images from MTC. At the center, the workflow used to obtain the flooding layer using the coefficient of retrodispersion method. So this information we call it comparable information because, as it's been said before, we did not have images with a better resolution for these 2 dates. And finally, on the right, the workflow of the optical image from which the information was obtained, reference information. As you can see over here, in all of the cases, the flooded area was obtained in the same way. That is to say, through classification, supervised classification and object level, and followed by a refining, which has been done manually. So in order to do the classification of the images, MTC images over here, we created an interpretation guide. To do so, we had the help of the optical image from A to B. The chart over here on the right shows this interpretation guide. So those pixels that have low intensity in both images and a coherence low medium corresponded to permanent water or flooded areas in both images in T1 and T2, and they presented a blue color. The pixels which had intensities medium high in the first and low in the second one, and low medium coherence correspond to flooded areas in the second images, like T2, and they had rather a pinkish color. And finally, pixels which presented a low intensity in the first, medium high in the second, and a low medium coherence corresponded to flooded areas in the first image T1, and they presented greenish color. So over here we have an example. We can clearly see some pink areas over here, which correspond to flooded areas in T2. And just tell you that the flooded areas in image T1, this greenish one, were deleted because what we wanted was to monitor the flooding growth for these 3 dates, for the 23rd, 26th of March and the 1st of April. The results of validation for these 3 dates were the following ones. We obtained a good agreement for the 23rd and 26th of March with layers higher to 0.8. An agreement was obtained when comparing it with the information of reference created from the rapid eye image. In all of the cases, the flooded category increased in comparison with the global one. The omissions were higher than the ones before, and the highest one was when comparing them with the reference information with a 35%. Most of the omissions were located in zones where the signal of Sentinel-1 indicated a possible presence of water, but the response in MTC image was not concluding. So here we have an example of it. And also we saw that the width of the optical of rapid eye allowed it to classify flooded zones which were shallow or zones which had a high amount of sediment, which Sentinel cannot detect. And finally, I want to tell you that the commissions for the 26th of March and the 1st of April were also small. In this last case, we implemented a method proposed by Joe et al., which is the one I mentioned over here in this reference. So, with the main goal to overcome the lack of HH polarization in Sentinel-1, this method exploits the double polarization of the images Sentinel to determine flooding. And to do so, they use 2 images, Sentinel images, the former one and the former one, pre and post images. Before and after the event, it is Harvey hurricane that got to Texas by the end of August 2017. And the study zone corresponds mainly to urban areas with a presence of some green zones. It is a flat and coastal area. In this case, we did not have any reference image from which we could obtain reference information. So therefore, the analysis had to be done only at a visual level. Images, pre and post images, were processed just like in the former cases. They were calibrated, they were rectified, centered. All of this was done in Snap. And these are the ones in this chart, 24th of August and the 30th of August. Both images, pre and post event images. Afterwards, they were passed to decibels, and the RGB was created, as has been mentioned in this chart over here on the left. The interpretation of the colors of image, RGB image, was done following the indications described in the former article. that we discussed about. So as it is shown on this chart on the right, black or dark brown indicates zones with permanent water in both images, pre and post event. And blue and purple colors indicates flooded zones only in the post-event image. Here we can see some other examples where we can see some permanent water zones over here, this one over here, the river, and the flooded areas as well. So as it's been mentioned before, since there's no reference information to validate this with, then we don't have quantitative data in order, for this case. So the conclusions, these use cases that we have seen have demonstrated the usage of Sentinel-1 images in the detection and monitoring of floods. In the first case, retrodispersion coefficient as a method for detecting flooded areas, it worked pretty well. MTC method, the results show that this data can show properly the evolution of the flooded areas, which are rather deep, but not the shallow ones, or the ones with high concentration of sediment. The third method, double polarization, allowed it to derive to some flooded areas, a result important in the context of emergencies. But as I told you before, we could not validate it quantitatively. So these three methods which have been presented could be optimized in order to produce flooding maps in real time, which are useful for the management of flooding events. But these methods, we can see that they work well over some quiet and shallow bodies of water. But the mapping of floods based in SAR had some limitations because the diagnosis were properly over urban zones with plenty of vegetation. We know that many studies are being developed in order to solve these limitations. And well, on our side, we will try to follow them closely. So that's all for now. I hope you enjoyed our presentation and thank you very much. Quite interesting presentation. Thank you. So now we have some questions. I will let you know about the questions. And first of all, Florencia is asking, what type of method of classification you were using?
Supervisada, contamos con el software de Feature Analysis, que es un poco caja negra.
Supervised classification. We include water samples and then some parameters, the size of the window, and it's automatically classified.
Software dentro de ArcGIS, que funciona dentro de ArcGIS.
Perfecto.
Inside ArcGIS, it works there. I have a couple of questions. You were talking about that the use during these last years of this tool had increased. Is that due to a better availability in images, or do you see that the effect associated to climate change results in more amount of urgencies? Have you thought of that? I'd say that it's a little of everything. Users of civil protection, they have more knowledge on this service as well. I don't know how you see that. I think that it's a mix. We believe that it must be due to the increase of the activations made in these last 4 years. And yes, it might be due to the image availability, but mainly I believe that both updated and end users are more aware of this service by Copernicus. That's exactly, yes, I agree with that. It is important that if you request a service, you have to know it. In Europe, we can see, and since in Europe it is more well known, it has more activations for European cases rather than cases outside Europe. But as the service is more well known, more users will be activated outside Europe. My question is associated to what Paula Hernandez was asking. In Chile, there's something that we call the charter of images, which is at some point when we have a catastrophe, a disaster, we're talking about big earthquakes and flood. In Chile, there's a protocol to be activated, and images are requested and they are submitted freely, even from commercial satellites. In that sense, when you talk about activation, does it mean that there are special requests? For example, that the satellite goes through a particular place? Can you reprogram satellites? So what do you mean when you talk about image requests? I'd like to make a difference with what you have said about charter in the case you're describing. Is request of images through charter. It is my understanding it is the international charter, right? Yes. It is in a way equivalent to Copernicus, but Copernicus does not provide satellite images. Copernicus provides maps derived, crisis maps, damage derived from satellite images, but it does not provide the images from the satellite. They are like pre-processed, so to speak. Yes, they have been processed by a consortium, and they do what we call savers provided or rapid mapping. They are those who have access to satellite images, and they obtain the crisis information, generate maps, and they deliver it to the users. They are maps, not satellite images, what Copernicus provides. Yeah, because I'm going to continue. If I want to activate the rapid mapping because there is a flood warning provided by our warning network, and at that time the satellite is not in the zone to cover the field, can product be obtained in that way? And well, sorry for my ignorance, but you see, she said that she's studying in this field. Basically, it is my understanding, but according to what she said, the flood has not started yet. Usually, rapid mapping service is activated when the flood has occurred, unless now that the early warning system contributes more information and everything is anticipated. And in this case, what I am not aware of, and that might be as to ERCC, if a country has their early warning system and they foresee floods, and based on that, they could request the activation of rapid mapping. That is what I don't know, and that ERCC is the one to decide whether to activate the service or not. But what's good about it, about this early warning system by EFAS, the one from Europe, is that besides contributing the areas of interest, AOI, the box tests, the square boxes or red or well, any form they have, they tell you about the area for which satellite images are going to be requested, and that normally users, when they see a flood, civil protection does not know what area am I going to assign for rapid mapping to capture images, whereas EFAS provides you with this AOIs, area of interest, which possibly will have an impact negative. I don't know if I had answered the question. No, very clear, at least to me. One last question by Florenzo. Have you used polarimetry to conduct this type of analysis? No, we haven't. Polarization, the backscatter coefficient and coherent, not the other one. Those were the questions. So once more, thank you very much. Very interesting. I hope that we can continue, and also the people who has joined us and listened to this conference. One of the important things of this workshop is to try to build networks of collaborations and to know those who are doing things. So once more, thank you very much.
Muchas gracias.
Thank
Obrigado.
you very much. In order to continue with our presentations, I don't see any other question. We're going to the panel now. The idea of this panel, will have 3 short presentations, around 10 minutes, so that in the end we can have a meeting with 15 minutes to have the Q&A for the speakers who will present now. We'll start with Mr. Luis Moya from the University of Engineering in Peru. He's a doctor in engineering from Chiba University in Japan. He was a researcher at Tohoku University in Japan. And he's currently a senior researcher at the National University of Engineering Peru. And his presentation is mapping of areas affected by the 2018 earthquake tsunami in Sulawesi, Indonesia, using Sentinel-2 satellite images. We have a 10-minute presentation by Luis, and then we'll continue with the second one. And the questions will be at the end of those 3 presentations. Any questions? Please write them in the chat. Luis, the floor is yours. Thank you very much. Can you see my slide? Perfectly. Thank you very much for the invitation. It's such an honor using these free access images, making the best out of it. Florencio asked me if I could make a presentation about this tsunami 2018 in Palu City in Indonesia. So I gathered that material. As you mentioned, when we want to monitor the affected areas, we usually work with all the material available. Not necessarily has to be Sentinel-2, but in my experience, it is always there. In this occasion, in this disaster, I work with these 2 groups, Sentinel-2. Some of you may be wondering why we didn't use radar images. Maybe you're not really interested in this area. Before the event, there were not many products. I see this in September, and Sentinel images, the last one, were registered in June. And the first products were the optical. Thankfully, there were some products free from cloud, so we focus on those products. The way we identify damage in infrastructure is in the comparison of 2 images, one registered before the event and the other one after the event. Then, this is the motivation of this work particularly. Something important we have to do to make comparison between those 2 images is to be sure that those 2 images are perfectly aligned, so we don't have misreadings regarding the improper alignment. So it's a pre-processing process, and important that must be done is the registration of images. And there's an example here, some figures to illustrate that. This is a technique called warping, where you detect control points to images, and then this method is applied to see that those 2 images are aligned. And that gives you the possibility to assess whether there have been changes and to deduce whether those changes are associated to the disaster. Most of these methods to do this warping or image alignment, they assume that the distortion to be applied will be a soft and continuous transition. And when there are some deformations, most of these methodologies do not work well. And this is something that happened in this event particularly. What I'm showing you here are higher resolution images to show you the motivation for this study. Here you can see the coast of Palu City that was flooded by the tsunami. I don't know if you can see Here in the left part of the image, you can see the fault. There's a deformation, a sudden deformation, a local deformation.
En el sentido de si es posible.
We started to see whether the co-registration of these images would be possible and whether this will be good. And particularly in this event, there was not only deformation due to the fault in the city, but also some other phenomena. Deformation in the field was pretty complex. And that was not the first time we found this type of problem. In this slide, we can see another event, an earthquake in Kumamoto, Japan, where once more the fault caused our area of interest in the affected place. And once more, we can question if co-registering, well, in this case, are images or satellite images, but the idea behind this of co-registering this technique. So we decided to wonder, is it really necessary to co-register, to align the images, to identify changes? And we start looking for alternative solutions to identify changes between those two images which are not necessarily aligned or not perfectly aligned. And then we started looking for some parameters that might be used. And basically, we focused on assessing these co-registration methods to know whether these methods are to detect any type of problem. We selected this parameter called phase correlation. This slide kind of explain how to speculate in this parameter. One image can be represented as a bidimensional image, and here I use the word the letter F, and another one with the function G, which basically represents the function F with a displacement x sub 0 and y sub 0. And if we apply this function in the frequency, we can see this ratio with this relation multiplied by this exponential expression with these terms where you can see the association to displacements here. If we multiplied the components with the conjugated from the other image, and then we basically remove the amplitude, we will obtain something that's called normalized cross power spectrum. And if we apply the inverted of Fourier, we will obtain phase correlation. In theory, these functions are continuous. What we should observe is a delta from that observation, and then we will see an infinite peak in the position indicating the difference in those two images. But in real life, we don't apply the dominion, the continuum dominion, but a more discrete dominion in the images. And what we have here are these results on the right of the images. More detail on the left part, we see two columns with images taken before and after. I included some yellow lines so that you can see that those images are not aligned, and I have applied and I have calculated these correlation parameters between these two images and the two first examples where we haven't had any collapse, no damage. And you can see there's a prominent peak here. You can see that in red. But when I apply the same method in a severely damaged area, there's no a prominent peak. Then the idea was to apply this, calculating this phase correlation and deduce whether we have some significant changes in certain events. We had been reading literature, and in the discrete domain, it's more complicated because the peak we observed consists of not only one value, but it consists by a set of a set of values where the top value and the shape of the peak gives you a lot of information. Then it was important to learn how to detect those values relevant for the assessment of the changes. Then we decided to leave this for machine learning technicians to detect the components of my phase correlation important for this analysis. Then we decided to assess it again in this event, the 2018 tsunami in Palu, Indonesia, Palu City, Indonesia. We assessed the method with these two images by Sentinel-2 and Planet images. This slide shows the study area on the left image. You can see the cyan pixels are urban areas. The one we'll focus on, and on the right, you can see how we built the parameters we will use to assess whether we have had some changes. The image has had 4 bands, the 3 classic ones, red, green, and blue, and the infrared band. And the first 2 columns you can see here, they represent a piece of the image taken before and after. The next 2 images are the same images, but by applying Hamming window function to emphasize image by the center and kind of ignore the edges to improve the resolution of the data, because we needed a significantly big window and improve the resolution of the results. Then we calculated the correlation of the phases for each band. You can see that in this column. And then we obtained the central part. We moved the phase correlation so that the top of the maximum is in the center, and we just selected a fraction of the phase correlation containing the maximum value in the center. If I'm not mistaken, it was like 11 by 11. And when we joined this matrix of the 4 bands, and this is like the signature of any of the infrastructure I'm going to talk about. Then, as I've been telling you, the next step was to identify which of these components are important to identify changes. And that was for a machine learning method. It's a standard method, which is a logistic regression. Is part of this regression model. And it's regularization. It contains a regularization protocol. It's important for this task was to identify what components are important. The coefficient, the C coefficient, kind of restricts the values. Okay, let me rephrase. The logistic regression is a linear combination of the values, excuse me, of this matrix I have generated here. And basically, the goal is to calculate what comes in this linear combination. Then, when using logistic regression with this regularization term, I restrict these factors, these weights I'm going to use in the combination. For example, if this C value is too small, it is -4, the coefficients of my combination will be close to 0. And in an extreme case, they will all be 0. So basically, my classifier won't classify anything, and depending on the weights of the operation, I have a performance of 50%, for example, here in this image we are watching here on the left. It means that my classifier is just selecting randomly. And as I increase this value in this C parameter, I'm giving more liberty to my linear combination, and the level of accuracy starts to increase. And here, in this image, you can see the values of these linear combination weights, how they vary according to this C coefficient. We conducted this study to assess and identify what components were important to detect changes, evaluating or assessing the level of accuracy we were improving. And at this level, there was no significant improvement on the accuracy level. These results here, I think, they are from Planet, and these are the ones are by Sentinel-2. I don't know if I am running out of time once. Okay, we're about to time so that you can sum up. Here are the results, the map, showing the red pixels are the changes we have seen. They are consistent with the flooded area by the tsunami in the coast. This blue line is what we map the extension of the tsunami. This is the lower part on the left. And something important is that we calibrated this algorithm with the information by Copernicus of rapid mapping. And something I wanted to emphasize that this area, it's an area that was not considered in the Copernicus assessment. In the area affected by the tsunami, and taking advantage of automatizing this might be a complementary tool to the work we did at that point. Okay, thank you very much. If you want more information, here you can see where we publish, we post it, and you have my email if you want more questions. Thank you very much. We have some questions, but they will be asked at the end of the session. Thank you very much.
Vamos a pasar con el segundo panelista.
We'll continue with our second panelist, Einar Borgio, Professor Einar Borgio. He is director of the United Nations Satellite Center in Geneva. He has got a PhD of geophysics and applications of high-resolution satellite emergency. He was in charge of UNOSAT operations, and he's been key for the building activities for disaster risk in Asia and in East Africa. He's going to present about artificial intelligence modeling.
Thank you.
Can you share your screen, please?
Yes, I'm trying to share my screen. It doesn't seem to work.
A ver, un momento, por favor. Sí.
Just 1 second, please.
Está.
Let me try here.
Ahora yo creo que sí.
Can you see it now?
Si podría intentar ahora. Perfecto.
Yes, we can see it. Perfect.
Thank you so much.
Por favor, adelante.
Yes, thank you so much. Thank you so much for the invitation to present here today. I really appreciate being invited. So I will speak, unfortunately, in English. My Spanish, I have a 1-year Spanish course, and it wouldn't do you justice. But nevertheless, I would like to speak a little bit about what UNOSAT, the United Nations Satellite Center, is doing in this field. We have a close collaboration with the Copernicus program, and we are good colleagues in these endeavors in order to see how we can best use satellite technologies in helping member states. So just a little bit of background information on UNOSAT. Earlier this year, we got the pleasure to be nominated as the United Nations Satellite Center by the United Nations in New York. And in that sense, we have been able to have several offices around the world. We have been able to support many countries over the time with our image assessment. One thing I would like to highlight is that we are based in Geneva in Switzerland, a part of the UN system, but we also have offices scattered a bit around the world, or I should say presence, because in Bangkok we have a good team. In Fiji and Vanuatu, we have people sitting with various government entities, as well as a regional office in Nairobi, and we also have one person sitting at the UN Operations and Crisis Center in New York. So we'd just like to speak a little bit about the rapid mapping service that we are providing. It's of course very much similar to the Copernicus one, but we have been doing this since 2003, and we have been working very closely with the Space Charter, the International Charter on Space and Major Disasters, as well as other entities. And I would also like to really thank Copernicus, the Copernicus program for the Sentinel-1 satellites and 2 satellites. Those are satellites that we are using a lot. So from our side, this service goes about various aspects of disasters or natural hazards, and we are able to use this technology using a wide range of satellite images, depending on what we're looking at, to really see what would be the most timely and let's say best type of data products that we can make. So those can be various types of products. It can be, of course, satellite analysis that we do. We do reports and data, and we also make this available through what we call web maps, and also making sure in this case that in many cases we have the ability to have photos from the ground uploaded onto the system as well, and we are able to then use the satellites based on requests from member states or UN entities, and also some NGOs like the Red Cross and Red Crescent family, etc. So we are looking at using this technology really to help countries in a very with a very fast turnaround time. Just a little bit of statistics. For the last 2 years, we have had 409 products, 102 activations in over 60 countries. And you can also see from the map that many of these are in Latin and Central America. One example of this is what we did in Guyana earlier this year. Here we had, unfortunately, a very serious flood situation. We also, at the same time, that was a coincidence, but we had a project in Guyana. And we were able to use our artificial call and national early action products so that we could directly help the government there. So as you can see here, what we are trying to do is that we are looking at various aspects of the flood situation. This was again a very serious flood, so it lasted quite a long time, and we are able to give statistics on how big an area has been analyzed, how big an area is affected by the floods, and how many people are affected, and also looking at roads that are directly affected by the floods as well. So we're trying to then combine the satellite observed information with tools and information that decision makers need to take decisions on the ground. And I'll send you in the chat after my presentation more information about this project. But also just, we're not only working on flooding, we are also working on earthquakes, and this is one example from Haiti, where we were quite active also this year when the latest Haiti earthquake struck. And of course, the way we do this is to compare images before and after, and then we have a very experienced team of image analysts that are able to then assess if the buildings are destroyed, what you see in the small red dots, or if they're more lighter damage, what you see in yellow. So this is how we work. This one was supported by the International Space Charter. But I would also like to talk a bit about what we do in terms of flood AI. What we have seen is that with the access to free and open data, such as the Sentinel-1 satellite, we're able to really look at flooding from a new dimension. From the UNOSAT perspective, we have been able to develop internally, also with partners at the UN Global Pool,
Estamos con pequeños problemas de conexión. Einar, ¿nos escuchas?
Einar, can you hear us? I mean, can you hear
Yes,
it? I mean, we are having
can
some
hear you.
connection issues. Maybe you can turn off your camera.
Hemos perdido un poco. Okay, we can hear you now.
Can you hear me?
Yes, we can hear.
Yes, we can hear you. Yes, we can hear you. You can
But can you
proceed.
see my
Continue.
slides?
We can see your slides as well.
Okay, thank you. So what we are doing is to really try to automatize this whole process, which means that we have, of course, a pipeline of satellite images coming in from the Copernicus program, Sentinel-1 in this case, and then we are having a whole team that has been doing training data sets. So in order to have an AI algorithm work properly, you need to train it, and you need to retrain it in order to have a good results. So once we have the results satisfactory, we put this into an operational service. So this is a bit how we work, and then we combine it with other types of information. Now this example is from Nepal, but I wanted to show it to you because it's really something very much operational, and it was used during the floods earlier this year. And what you can see here is that we're really trying to combine various types of information. Of course, again, here you have the automatically detected the population exposed, the inundated areas, how many square kilometers we had for it. And also, if you look at the right, you can see also by municipality how many people are exposed to the flood. You can also look at the temporal aspects at the bottom here, looking at how many people are exposed over time. So I think this is something we'd be very happy to also do in Latin America. This type of dashboard, because I think from a decision maker perspective, this is really important information. So, and again, it's a fully automatized process, and but we do need to make sure, of course, that the results are working, are well defined, and are at the let's say quality that we need. Now, also, of course, I mean, most of you are probably familiar with this, but I would like to highlight the access to current information, of course, is fundamental when it comes to satellite imagery, because we can also, as I said, combine it with other types of information like land use and infrastructure. And then we can, of course, also go back in time. We can also compare images and other previous floods events to see, how bad is it this time. At the same time, we're also trying to, and I come back to this, to really see how we can access this to future climate information. So we can also overlay future scenarios with the satellite and ground data to better understand the potential scenarios for strategic planning purposes. So this goes into then, I would say, more preparedness work, which is part of the whole, of course, disaster management cycle. And also to better understand existing and future risks, it's important to have natural hazards and the community vulnerability level with information on population, agricultural production, and for example, infrastructure. So I just want to highlight one project. Of course, this is in Fiji and Vanuatu in the Solomon Islands, but here we have developed a decision support system for enhanced disaster risk reduction. And again, this can easily be duplicated also elsewhere. So here we have access to current information, we have access to historic information, and we have been building an understanding of future climate and risks. So, so the end users of this information, of course, technical experts at the government level, as well as sectoral experts, decision makers, and also secondary regional users, because it's also very important, of course, to include regional capacities when we talk about this. So one tool that we have, or basically have developed 4 tools. One is descriptive analytics. So this is also been used, and here we have also collaborated with the Joint Research Center of the European Union, and here describing the analysis in terms of risks at the subnational level. Then we take this one step further. We look at the diagnosis and see how this risk index is
Einar, we lost you. You're cracking.
Einar, can you hear us?
Einar, you broke. We lost your signal. You're breaking. Can you hear us?
Oh, we lost him. Lo perdimos. Se desconectó Einar. Ah, ahí volvió.
Can you hear me?
Yes, now you can we can hear you.
Okay. Yeah, I don't know. Maybe my internet is a bit unstable. So anyway, this multi-criteria decision analysis tool allows decision maker to themselves weigh the different vulnerabilities so that they can themselves see how should they weight different things in order to take the most informed decision. And then, of course, we also work closely with the other types of data quality assessments. We work with the OpenStreetMap community, looking at different types of map coverage, and also
podría compartir.
You maybe you can share your screen. You're not sharing your screen now, so can you please share it?
We cannot see your slides.
You cannot see the slides?
Yes. No.
Can you see them now?
Not yet.
Ahí está.
No?
Now, yes.
Now we can say it, yes.
Okay. So basically, when combining all these tools, what we have also seen is that very often there's a lack of national capacity for using geographic information technology applications and accessing and analyzing and visualizing. From our experience that often at the government level, there's scattered information with no central point for data sharing facilitation. And also sometimes the cost for advanced GIS tools can be very high. So what we are doing is that we are providing capacity development services. And here we have been working a lot with the different around the world. This example is from Fiji, but really we have been working a lot around the world with various national disaster management offices. And we're able to provide them with the tools and with the information that they need in order to be best prepared for future scenarios. So and then again providing them with the tools and the information that they need. And one such tool can, for example, be the flood AI dashboard. So sorry for this being a bit interrupted, but I hope it was interesting.
Muchas gracias, Einar.
Thank you very much, Einar. It was really interesting presentation. At the end, we're going to have some time for questions. And we're going to continue with our last panelist. María Eugenia Sevillano. María Eugenia, are you here? Are you with us? María Eugenia, she's from Colombia. She's a teacher at the public management. She's a doctor in urban planning, specialist in this topic. She's a geographer, and she has some publications about hazard vulnerability and flood risk analysis. She's going to present a case study in Santiago de Cali, Colombia. So please, María Eugenia, you can now share your screen. This is a brief presentation, 10 minutes, and at the very end, we're going to have a Q&A session.
Por favor.
Ahí se ve.
Okay.
Yes, we can see it. We can see your presentation. We're okay. Thank you very much. So as it was mentioned, this work, it is hazard, vulnerability, and flood risk analysis, and the case study in Santiago de Cali, in Colombia. So in this work, we need to take note that it is the result of a research, PhD research, and I want to thank UNICID and Ciudad Juárez University and the PhD in Urban Studies. In general terms, in Colombia, these hydrometeorological situations are quite common, and we have vulnerability cases of the population. Therefore, it has been required to manage and to find a way on how to reduce this type of situation. So it is quite important to study the flooding in cities, and Cali, it is a good place to do this research.
Colombiana, no me voy a detener, pero sí encontramos en términos generales unos planes de gestión de riesgo que permiten favorecer y mitigar este tipo de situaciones que se presentan. Acá encontramos un poco lo que se establece en las administraciones municipales para mitigar esas condiciones de riesgo, y es importante para mí anotar que este trabajo se basó básicamente en 4 conceptos, elementos conceptuales. Uno es la amenaza, o conocida en Europa como peligro. En este caso la entenderemos como la valoración a partir de la probabilidad de inundación de una ciudad, la vulnerabilidad estimada desde indicadores extremos de desigualdad social y accesibilidad, el riesgo desde la combinación tanto de amenaza como vulnerabilidad, y algunos elementos expuestos que corresponden a aquellos elementos que puedan encontrarse en esas condiciones, ya sea de amenaza.
To those elements that might be found in that image. The intention is to identify those conditions, and based on that, we start studying the Santiago de Cali city. Is a city located in the southeast place of Colombia. Here it is located, is a mountain zone, and in the hydrical system in the urban part, it concentrates 7 rivers and a set of channels that have been built to mitigate these flood issues. We have 2 times, some rainy months and some winter months that generally go from October to December and from March to May. In general terms, the city has suffered from some social demographic transformation, making it an interesting city for arrival, and it's one of the main cities in the country. From there, it is important to say that the growth of the city has always been associated to the 7 hydrical sources located in the city, and since 1960, channels have been built to mitigate flood, but those started to be used for those people in need of housing to live in those places. So they start into these rudimentary feelings where they start to place their housing. Here we have several associated problems, and Cali starts to grow towards the east zone and the west zone. In the east zone, we have a fluvial area, and in the west area is a mountainous zone with sources of some hydrical sources whose origin is in those places. This is how you can see Cali from the west part. We can see how the city has grown. What we see here is what has happened in the flood. These are pictures gathered from information from the news. And based on that, it was important to say that what happens in Cali around that vulnerability, risk, and threat. First was the threat, and to do so, we follow classification supervised in the images of Sentinel-1 from a date before and a date after the event. It was necessary to validate that information. This is why we went into field work to gather information around the floods being presented, and that allows us some variety. The images are subject to a calibration and correction radiometric process, and it was important to determine what was the layer indexes to observe the kappa index to see how much we could validate. Those are the results. We obtain a flood plate, as been mentioned before. You can do this triangulation process, and then with the review of information, we can establish a period of return of 1 point here. That's the information gathered with the floods occurring in the city. And this is done since 1986 until 2018. This is what's done in the field. We start validating information. This exercise is executed for all the cities. The determination of the cities being flooded is conducted here as a result of the flood plate, and that corresponds to the information provided by bibliography, allowing us to establish the places. Then the population start analyzing the extent of the flood and what was happened based on that. In yellow, you can see the validation information. Yellow represents the groups of information we can have access to. Then we have the flood plate, and that's how the validation process starts, and we obtain an index of validation of 89%. Based on that information, I have said that we have a flood plate determined by the procedures of classification supervised, but we want more. We want that flood to be classified somehow. And to do that classification, we start using a different method, which is the multi-criteria method. That method allows us to adhere to some other parameters, and those parameters allow us the classification. For the use of this method, we go to different authors who had used each of these components. One of the most complicated was to establish the depth. The depth determined from the digital model of elevation. And besides, we found some others such as the flow accumulation, the nearness to channels, something important, nearness to rivers, the slopes, wetlands, and the gorges, or smallest hydrical sources, as we call them in Colombia. That process is subject to a weighting, and this is how we establish the weighting parameters. In this case, at the time or to the factor which receives more weighting is precisely the depth, as you can see in this graph. And that work results in this. We had a high flood in the zone, highly associated over the main channels found in the city, which is indicating that what produces most floods is the presence of channels, and affectations toward the east, where you can see the zone of the Cauca River, or the main rivers of the city located in the east. Based on that information, we start defining which places start to present, or in which places we can see a type of flood, high, medium, or low, according to the return period and what we had established. And this is what we start doing. We start determining those times and verify them with the news or secondary information gathered from different sources. What we achieved was to detect this through a multi-criteria parameter. Then it is important to determine the vulnerability in an area like this to verify the association presented between these threat conditions and that vulnerability, let's say, of the socioeconomic or territorial type, as we have called it. In this case, we start finding that most vulnerability and this is why I'm showing you this slide, are found in the east and the west part of the city. Those who have the opportunity to come to Cali will see that most of the vulnerability in terms of socioeconomic definitions can be found precisely to the east and to the west of the city itself. We can also verify that on these areas we may find low resources population due to the same historical reasons start to settle down in those places and they start to refill in order to build their housings. What we can also find here is where those settlements, informal settlements, are located in the city. We can see and confirm that it is in the edge of the river, and we can also say that they are found in the mountainous zone of the city. Something that can be verified is that the last administrations of the municipality have used elements from what's public to start providing better life conditions to those settlements. However, they continue to be in the same condition. That's an image of a journey done in those east zone. That's the conditions of those informal settlement. That's an image taken in 2018. And here we have an image from the news of what can be the affectation in one of the east areas of the city. Based on that, it was important to determine what the risk of disaster when facing those threats and vulnerability conditions. And then this method is proposed, which is the synthesized model of mitigation, as we have called it, and basically the possibility to gather those threat, vulnerability conditions, and the addition of those two elements will result in the disaster risk. That allows us to determine which are the exposed elements that might be affected in the case of an occurrence. When obtaining this methodological base, we do this combination of threat and vulnerability, and this is how we can establish that. We have to remember that in this case, the threat conditions are based on the elements we have integrated in the previous slides. Here we can see vulnerability associated to those conditions in the community, where we used statistic tools by considering one of the last population census, and the risk is the combination of both elements, such as threat and vulnerability. And this is how we can obtain the information. What you can see there are the zoning of the threat in the first slide. And here we can see the vulnerability elements pretty similar to how the threat is presented. And here we see the result of the combination of those two elements, threat and vulnerability, which results in a risk cartography for a city like this. We can clearly confirm that these elements are concentrated much more in the east part of the city, and this is pretty connected to the presence of channels in the city. And this is how we can determine what the elements of risk are, and that's an example for the neighborhood that might be affected during this return period, 34 neighborhood, 37,000 families approximately, and it's another type of element here, which is such as the tap water plants, education centers, among others. With this, it was important to see how that urban growth has favored those vulnerability patterns, even of informal settlements existing around the city, and those settlements associated or located very close to the main hydrical sources and the main channels, which capture all the water in the city. And here what we have is the result of those threat vulnerability elements concluded or ended up in a cartography. And here, finally, I have to say that based on the considerations obtained from this study, you can see a hazard of threat by flood, and they are vulnerable clearly, and that vulnerability is associated to historical, socioeconomical, and territorial processes of the population. They are in risk. They really are in risk because they are in a hazard area. There is a social construction of risk because vulnerability of the population has been the object of threat by flood. In this case, the risk and territorial mapping is a key element to establish urban planning and public policies for mitigation, enabling better conditions. In general terms, this work contributes with methodological contributions starting from a basic premise, and is the risks as a social construct. And this premise, based on this premise, some contributions start to be made in order to identify the conditions, such as the vulnerabilities and threats, and the estimation of the exposed elements in case of disasters. And that would be my presentation. Thank you very much. Thank you very much. We're going to continue with some questions we have now in the chat. One question for Luis. First, if there is any automatic way of estimation the regulation parameter. And there is a second question also for Luis. It's a very interesting presentation. And what was the calibration conducting the study about, how Copernicus data rapid mapping were incorporated? Maybe you can answer.
The first question was this regularization. Is there any automatic way of obtaining that information? Our main interest was not to set an automatic process, but to know which of the components of the phase correlation were important in order to automatically use those components in future events. But if you ask me about that, yes, it is possible by using, in this machine learning techniques, you need to use training data and try to find a balance between the minimal number of coefficients to obtain the maximum value of precision or accuracy. If you see my slide, let me just share the slide once again. There, you can see my screen. So we'll spend a couple of minutes here. These three charts show some variabilities about this parameter, which is related to regularization of L1, of this one over here. So this C affects all of the equation and also the regularization term. But when the C value, it is small, the coefficients are almost nearby zero. This one shows the values of all of the coefficients, 481 per each sample. So when coefficient it is rather low, it makes the whole coefficient to be zero. So basically, the classification is not allocating any label. It is the same label for all of them. And therefore, we are having a 50% of accuracy, which is a random behavior. So when we increase the value of C, then we have different coefficients, different from zero. This graph shows the percentage of values of our coefficient, which is different from zero, and this is the accuracy level. So the accuracy level, it is higher here. When we have the first weight in linear combination, the accuracy, it is increased in around 75%. And as I increase the C value, my accuracy, it is higher, but there's a time when the improvement, it is not important or significant. So optimizing, it is related to having a minimal coefficient different from zero. Why different from zero? Because that makes the classification. And that is called optimum, right? We need to do the multiplications. Thank you. Thank you very much. How about the validation? Yes, we used samples, training samples, and we use a little bit of what we saw when we checked, what we obtained at the city, and the reports from rapid mapping from Copernicus. So we selected 4,000 buildings, and we made a common practice when you calibrate these machine learning algorithms. I don't have the image here, which is called template. We have 4,000, and we create 10 divisions, random divisions. We use this to calibrate the algorithm, and the ones which are separated are used to the assessment. So we repeat this technique 10 times, always separating one group or the groups from each other, and with that we assess the accuracy level. And at the very end, we could ratify that the algorithm works, because this area over here, F17, was not in the A or I's of rapid mapping, and we could detect it. Thank you. A question for Einar. Which is the mechanism of activation of the support system of UNSAT? Are you with us, Einar? Maybe we lost Einar. Einar, are you there?
Estaba con algunos problemas de conexión, Einar, al parecer.
Einar had some connection problems. So we lost him. A question for Maria Eugenia. When you talked about classification elements, what type of methods do you use for the classification? What type of techniques are you using? The classification, supervised classification, it is a method which is being used for, in this case, it was used for the analysis of plottings. It is also, the platform that we used was Snap, which is of open use, and it was also the RGS was also used. So we're talking about the supervised classification because we recognize the supervised and the non-supervised, and in this case, we use the supervised classification. Perfect then. Einar, can you hear us, Einar? Did you listen to the question? Could you listen to the question? We had a question for you. The question was, which is the mechanism of activation of the support system of UNSAT?
So what is how to trigger UNOSAT rapid mapping?
Exacto,
Yeah.
exacto, sí.
That is correct. Yes, that is correct.
In the chat, actually, there's a very simple procedure. So I will put that in the chat, and you can just basically it's just to contact us via a dedicated email, emergencymapping@unosat.org, and then you can trigger the UNOSAT rapid map. But I'll put it in the chat so that this is open for UN entities, for member states, and other organizations.
Muchas gracias.
Thank you very much. Well then, so with this, we're going to close this panel. I want to thank the three presenters, speakers, really interesting lectures. And now I will give the floor to Carmen Gloria. She's going to comment, she's going to let us know how we will continue with our morning or afternoon. Thank you, Jaime. It's been really interesting, different viewpoints in order to analyze all of this topic, and therefore this opened our mind to have discussions to identify different issues and problems. So now we're going to have a 5-minute break, and afterwards we're going to work in the breakout rooms where you can go deeper into the topics that you have seen here. And the idea is also to create this collaboration networks, identifying different gaps, projects, joint projects, So we have assigned the rooms already. The main room, which is this one, which has simultaneous interpretation. It is risk monitoring and prevention. We have room number 1, which is risk analysis and management, and room 2, impact measurement and recovery. So before you go grab a coffee or some water, we are going to run a test. These breakout rooms are going to be activated. So once you're back, the rooms are going to be already set. And if in a room you are not comfortable and you want to move, you can do it. And you can go to a different room. So Florencio is the one in charge of this section. He's going to invite us to the breakout rooms. And afterwards, we can have a 5-minute break. So let's go to the rooms.
Florencio, todavía sigo en la sala principal.
¿Qué sala está, Javier? ¿Está bien?
Soy Gem.
Creo que esa es, ¿no? ¿La tuya?
La mía es la sala 1.
No, pues tú deberías quedar en la 1. Vuelve, sal, tú mismo cámbiate.
¿Yo? ¿Estás hablando de mi Florencio?
Okay, I hope everyone is back from their break. Thank you all for joining us and for joining this breakout session. Oh, yeah, hopefully I can see people back. I'm Izzy Hassel. I'm from the Joint Nature Conservation Committee, or JNCC. I'm afraid I'm going to be talking in English because my Spanish definitely is not up to scratch, but please speak in a language you're most comfortable in. There are the interpretation is available in this room. So at the bottom, you can select your language of choice. Please let us know if you have any issues at all, though, and thank you again to the interpreters for doing such a great job. So the aim of today's session is to identify and share problems of common interest, any potential solutions that we can think about, any projects or collaboration ideas, any lessons learned, and using Earth observation data, and in particular Sentinel data. So the results of this activity hopefully could be things like ideas for possible collaborative projects, any problems that you come up against in your work that require a solution, or any areas of collaboration in future. So we've seen some fantastic presentations on floods earlier today. So what we're going to do in this session is think about in hydrological hazards, where Earth observation data, and particularly Sentinel data, can help us to monitor and forecast these flood events. So for example, developing early warning systems, as we heard about earlier. So we'd really like to hear about any ideas you have for monitoring or predicting flood events. And as I've mentioned, this is a real opportunity to identify any potential projects. So hopefully you can all hear me okay. Do let me know in the chat or raise your hand if you can't. But this is basically a discussion session where please feel free to raise your hand or unmute and speak, or pop any messages in the chat function if you'd prefer. So to start off with, and as I say, if anyone's got any questions throughout, please do just let us know. So to start off with, if we're thinking about flood monitoring and forecasting, does anyone have any thoughts about what they think about current methods of how we monitor or forecast flood events at the moment?
Excuse me, Izzy, this is your interpreter. You're muted.
Oh, thank you. Sorry, I was on mute there. If anyone, yeah, what was I saying? If anyone has any ideas of any problems that they face when they're trying to monitor flood events, or any kind of problems they see either in their own countries or in a worldwide scale. Have people in the past used things like early warning systems, as we'd seen examples on from earlier today? Or is this kind of a new area for people? So Esperanza or Aaron, thank you again for your presentation earlier. Do you see people, do you get a lot of people kind of giving any feedback on the early warning system, or are people kind of use it? How do you find the uptake of the early warning system?
A ver, no sé si te he entendido muy bien la pregunta.
I don't know if I have understood your question. Can you repeat it, please?
Sorry, yes. So just thank you again for your presentation. Do you find that people have, is there a lot of uptake for the early warning system, or does anybody struggle to use the system, or do you think there are any improvements that you would like to see?
A ver, estos sistemas de alerta temprana.
These early warning systems, I can talk about the one from Europe, which is the one I know. One of the centers of this early warning system is the Center of Data Dissemination. And this center, they have or they get a feedback from the users using the early warning system products to identify whether those products generated by the system, which is EFAS, match the, in other words, it was being foreseen or predicted is what happens later, the floods, and they have a feedback with the users in order to identify that whether this works well, if there is an improvement is needed for the models of early warning systems, then it is them who take control or who get to see or to say whether this worked well or not and what needs to be improved. This dissemination center contacts other EFAS centers and they tell them, well, in this forecast, in this prediction, these concrete floods, it didn't work well. The modeling or the simulations to identify the flood needs to be improved, but it's something that is within them, between the uses of the early warning system from Europe and the EFAS itself. But, well, what I do believe that users of these products have a lot to say, because they are like the reality in the field. They will see whether this, which has been modeled, meet the requirements or not. What was predicted happens or does not happen. So at any place where you can have this early warning system worldwide, I don't know if Chile or any other country has, but what's essential about it is the communication, the contact with the users of those products. This is what I do believe it is essential. And then, of course, the way to improve that might be in terms of improving the models used to predict or forecast, to validate them. I don't know if I have answered your question.
Yes, definitely. Thank you very much, Esperanza. Thank you. Gabriel, did you have something to add? Sorry, there was a hand up from Gabriel. Did you have something to add?
Hola, hola, hola.
Hello. ¿Me escuchas? Can you hear me?
Yes, we can hear you, yes.
I would like to know if is there any methodological way to learn how to use interferometric SAR. Yo realmente lo que quiero saber es si efectivamente hay alguna...
What I want to know if there is any methodological route to know it. I'm very new in the use of the methodology of these resources, of these supplies, and then based on what Esperanza has said, I would like to know if there are any standards or protocols or some methodological guidelines to help me understand what would be the proper way to start learning how to use these resources for the landslide analysis and floods, including not only the proper use, meeting quality requirements, but also the vision as an end or final product. That's the comment and question I have. Thank you very much.
Yo no conozco, no sé si mi compañera...
I don't know. I don't know if my colleague knows those protocols or those methods to read or to interpret the interferometry methodology. I understand that scientific articles for a user that's not technical or not knowledgeable about it. And I don't know, I'm not aware if there are any simple protocols to interpret or to understand the methodology. But what it is true and something that was commented on yesterday is that, for example, by using or with the maps generated by Copernicus, with interferometry, what's important is that the technicians knows how to interpret the interferometry. But the idea would be that when creating a map for a concrete user, that user can interpret or can be well explained of the results. Those maps are pretty beautiful, you know, but they may have an easy interpretation so that users can use and get the best out of those maps. I think that's essential to be taken into account. And well, I haven't been able to be all the presentation, but I would like to know if there is any document. Well, I understand about scientific articles, but you may know any type of document, as you say, a simple one, like a step-by-step guide, giving me some clues on how to correctly use these resources, because resources are there. Sometimes you may use any application, process, or tool, but I may use it in an empirical way without having a knowledge or a notion on how to use it. What I can answer is that I fully agree with what she has said. In the end, it's not only having an interferometry map, you need to know how to interpret that, what those maps are showing you. I don't know, because I've been for years doing one thing from here and one thing from another, but what we have used to process is a Snap, which is a free access from ESA. And I have put the link in the chat. Within Snap, there's several tutorials, quick guidelines. You may glimpse that and you might find something interesting there. Thank you very much. I haven't used that for interferometry, but to me, I know that there are plenty of progress and advancement in Colombia, a country with a very high vulnerability for landslides and floods.
Bueno, gracias.
Thank you. Thank you.
Thanks both, that's brilliant. And thank you, Aaron, for putting the link in the chat. Thank you. Eduardo, did you want to say your question? Who was that to anyone in particular? Eduardo, was that a question
Perdón,
about?
veo una pregunta, a ver.
Oh, sorry. Was for.
Creo que quizás Aran estabas
Maybe,
contestando.
Aran, you were answering, weren't you?
No, que no lo he leído, perdona.
I haven't read it in the chat. Excuse me. If there is any way to add information considering population, historical maximums of floods, quantified scales, to include this information in the conducted models. I don't know if you, Aran, can answer that question. Including population, like adding a different layer, right? Because in the end, what we have done is to remove the spot from this flooded area. You may add, it's been said.
A no ser, Espe, que se refiere a los modelos de...
Unless you mean
que has comentado tú, los de alerta.
The models you have commented, those early warnings models. Well, we don't work with those early warning models. Maybe it can be transferred to EFAS when it comes to the question, of course. I wouldn't be able to answer that. Unless, as Aran says, probably one additional layer when it's talk about those models which are managed, such as risk management. Well, for a risk management model, including population is fundamental. It's one more additional layer. As a matter of fact, I think that's included, yeah, because it's pretty basic. It must be included. I don't know how they do that because I'm not a technician of them, but EFAS, when they do those flood impact modeling, when they do those risk models, certainly they include hazard maps, exposed elements. One of them is, of course, population, and then their vulnerability. But rather the number of population, but as territorial knowledge by users. I wouldn't know how to say that. I don't have enough knowledge to answer that.
Great, thank you both. Carmen Gloria, did you want to come in?
Sí, yo no soy conocedora ni trabajo específicamente.
Well, I'm not knowledgeable about this subject, but I have a question, particularly when thinking what Latin America can do in countries such as Peru, Colombia, Chile, when we are facing disasters constantly, in a way to improve prevention, management of disasters. Then, in that sense, my question is, it is my understanding that someone from Latin America can access this service. If it is like that, is this, for example, for prevention or for the emergency itself? That is, if I belong to a geological service or I am part of a national disaster office, like in Chile, can I permanently requesting services on the monitoring of a specific zoning? That would be one of my questions, my first question. Yes, you can request if you had gone through an earthquake, for example, as we were saying, the top authority, that would be the authority. Well, I mean, you will have to contact ERCC, which is the Response Emergency Center, and you have to contact them to trigger the rapid mapping service so they can generate maps on the damage caused by that earthquake, building the extent of damage in those buildings, damaged buildings, extent of damage. Yes, you would have to request them on that information. They will have to analyze according to the criteria analysis if the rapid mapping service can be activated. But besides the rapid mapping service, you could also request the risk and recovery mapping service, which is in case you would like to have hazard maps when facing any type of disaster, or risk maps when facing any type of disaster. Then in that case, you could ask the risk and recovery mapping service the same. And there are several types of products you could request. For example, risk maps of vulnerability, exposed elements before any type of threat or hazard. There's several products that this service of risk recovery mapping can provide you with to be prepared in case of a disaster or for the recovery after the disaster. Clearly, you can request both services, and in both cases, what you would have to do is to contact ERCC to make the request for ERCC. In my presentation, I have put the link, but also the email of ERCC so that you can email them and send the request for the triggering of the services. And sometimes they analyze criteria. For example, you have a very broad area you want to study. They can limit you. They may say, okay, that's a big area, it should be smaller, and they can communicate when to activate the service. But definitely, everyone in the world can use the service, both rapid mapping in case of a disaster has occurred, or the risk and recovery mapping to be alert in front of a disaster. Thank you very much. One more question, Esperanza, is what are the difficulties you face during the emergency itself? For example, in La Palma volcano, where you are permanently monitoring that. Our company, actually, we do not generate rapid mapping or damage maps. of these risk and recovery maps. What we do is to act as a validation tool for those services of the products generating those services. The GRC, which is the Copernicus management service, has this validation service where we are to see or to monitor when any country requests for a damage map, for the risk and recovery mapping or for the damage mapping, to see how well those maps have been created, see what the methodology used is, whether they have failed or succeeded. The GRCC even asked us to propose new methodologies to create those new damage maps. And this is why we are testing new methodologies. The only thing I can say is that the information we develop can only be offered to the GRCC. What I told you before, unless we have published the work, we cannot offer publicly, we cannot show them publicly because it's something we have been asked. And we do that only because GRCC does that, which is the one managing the response management service. Thank you very much. Thank you very much.
And thank you, Carmen Gloria. Thank you, Esperanza. I'm not sure, Carmen Gloria, do we, how much time do we have?
Ya voy chequeando.
I'll check on time. Something I think it's important to say is that from Copernicus Center in Chile, you have to inform these possibilities to request those services are available for the country or for all Latin America. Maybe the lack of information is what's an obstacle for the users to access these services and the products generated by these services. I think that's pretty interesting, particularly in our country, when, well, we do have plenty of disasters, a lot of melting volcanoes, and we usually see we didn't see that coming. Or the question might be, how didn't you see that coming? We have made progress, of course, but I imagine that in other countries, there's a similar situation. Then it is very important, that information. Thank you very much.
Thank you, Esperanza. It's a good point about making sure that people are aware, and I think definitely your presentation earlier has really helped to explain the process.
Creo que la descentralización es clave y el autorrespaldo también.
Lisa, do you have a question?
Yeah, sorry, my video was off. Yeah, I was interested. I think I didn't quite understand. Could you maybe explain again when you said the large part of your work is the validation of these mappings? What that process is? Is that based on field workers that then go out to validate results, or how exactly does the validation process work?
Quizás aquí Aran puede completar porque parte de la
Aran can complement because part of the presentation, of her presentation, was about the validation of some of the products generated in the rapid mapping service. Actually, making a comparison of what's being done in the service rapid mapping with doing the same but with better reference centers, better satellite images with better spatial resolution, and so on, and to compare the results. But Aran, who's an expert, can give you details of. Well, that's more or less the idea. And the first point you need to be clear about is that we work once the event has occurred. Service provider works when the event takes place. When the flood, the earthquake takes place, we do the opposite. We get those maps, we check them whether they are good or bad, or if they have been better. But after that, prior to the event, then if a map has been generated with a sentinel image, in order to do the validation, we need reference information, and for that, better resolution image or information gathered in the field, in situ. Then the GRC provide us with that information we can use as a field information, and then we cross it and we compare it with what the service provider has generated. I don't know if I have explained myself well.
Yes, yeah, definitely. I was just wondering, especially when it's about flooding and emergency response, how long does it take? Is then the validation, is that for future improvement of the mapping service, or is there an element of directly improving the response when there's a problem with the map or the map isn't quite accurate? So if you can you, from that validation, is that, how long does that take essentially to do the validation process?
Nosotros, a ver, las validaciones las hacemos en...
Well, validations take 1 month. 1 month.
Okay.
And actually what we need is the feedback, and as has said before, Esperanza has said before, they anyway ask us to test, to improve new methods, to see whether they can implement that as well. Or to observe if the best image has been used. We also give them some feedback so they can improve the service.
Okay, thank you.
Que los mapas que hace el
We need to take into account that the service provider maps in the service of rapid mapping are done with a very little time, because they work under emergency and the urgency, you see, so they need to have as soon as possible a map considering the damage that has been caused. Then the service provider has very little time. In theory, what takes most time is acquiring images. Having the images, this is why the anticipated request is a good element. But since the service provider receives the satellite image, they just have 7 hours to generate an alignment flood map. That limited time is what caused more mistakes when generating the map. When we do the validation, we do the same work the service provider does, but we have more time because we have the possibility to search for better reference information. The service provider, when they have to generate maps, they just capture the first image after the event, and that's not the best image. They do not have more time to look for something else. They need to do that quickly. When we do validations, we take time to look for the best images possible available, but they didn't use them due to different reasons, because they didn't have enough time or any other reason. Then the validation service is to offer improvements to this rapid mapping service. So then the service provider, we can give some recommendations on how to improve the service, useful for the service provider when they are to generate the maps in a crisis.
Great, thank you. Thank you, Esperanza. Thank you, Lisa. I think we've run out of time. Michael Cooper did have a question in the chat. If Esperanza or Aran, if you're able to answer him in the chat, that would be great. Thank you. And I'll hand back over to Florencio. Thank you.
Una persona independiente puede solicitar.
An individual, any type of individual, can request a service, but I'm practically sure that the ERCC would not activate it, would not approve of it. There are several criteria that need to be met. What is being requested should be of relevance for the country. It needs to be confirmed that the impact of the disaster has been relevant to big, so they can decide to activate the service. And any type of individual, an ordinary individual making the request, might be ignored, or maybe ERCC will not activate the services. And maybe that person will not be able to request that. They need to go to civil protection of the country, the top authority, in the case of European countries, or to ERCC directly, in the case there is a country outside the European Union, in order to request those services. And as I see that the question is from Mexico, then they would have to contact ERCC to make that request. But chances are they do not meet the criteria to activate it. Isi, do you have any more comments or questions so that we can go to the summary of the sessions?
Sorry, no, that's us finished. Thank you. Thank you, Esperanza. Thank you, everyone. Thank you.
Gracias a vosotros.
Y vamos a pasar un poco ahora a resumir un poco lo que se conversó.
Now we'll go for the summary of what's been talked about in the different sessions, so that we can sum up and start closing this morning, evening, night, depending on where you are. We'll start with easy in the monitoring and prevention and forecasting. Maybe you can tell us a little briefly, of course, what was talked about. Thank you very much.
Thank you, Jaime. Yes, we spoke mostly about the importance of communicating around communicating the potential for monitoring and forecasting. So with the early warning systems, making sure that people know that this service exists and that people can request the data and how to go about that process, as well as communicating the model outputs in a way that lets people know any kind of limitations of the model and what the model is there to do. So we talked a lot about the importance of communicating for the users.
Muchas gracias, ¿verdad?
Thank you very much. On measurement and recovery, maybe on the other room, you can tell us a little of the summary of this, of that room. Thank you very much, Jaime. We were in impact and recovery mitigation room, And during our conversation, what we could consider was that there's an open microphone. Maybe it's, I'm listening to Samiko. Well, what we consider is that the geospatial and geosatellite data is pretty focused, in particular for the quantification of the disaster, the post-event, whether this is for watching people being affected, considering associated costs, all of this after the catastrophe. But in this context, we may consider that more effort is required for the management of early warning system and for the risk management, and all these along with public policies. This is crucial since we have well approached the quantification and mitigation for damage in the recovery tasks. But on the other hand, in recovery, probably if we have some sectors that were affected and quantified, what happened after that? Then we are back again in most of the cases to build again in those affected places after tsunami, floods. There's no public policies, clear public policies to avoid building or other type of events. We are like in this loop, you see in this vicious circle. Then effort is required from the technical part, professional part, as well as from public policies. And finally, we also mentioned, and that was a frequent conversation, we need support systems, a backup system. All of this is worked around computing, internet, but when facing catastrophes, what may happen is that many of those systems froze and do not continue to work. We need a quick response for some institutions, emergency institutions, and how to transfer or how to provide some management for the data so that it can be transferred to the institution themselves, and looking for some options so that we can have these redundancies that sometimes are inexistent when having the catastrophe in 2010 in the earthquake in Chile, communications cut off. There were no system of communications among institutions allowing us to access everything quickly. And finally, to close, because we talked about different topics, but one of the most frequent or recurrent subjects was the redundancy, bureaucratic redundancy in many cases, for the access precisely to this information, the decentralization of the processes. An institution may generate the data after transferring to other that's been centralized in Santiago, and then returning to other institutions. There's several cases when these redundancies do not enable to provide a quick response, an agile response when facing an event, and that's something that needs to be better managed, hopefully within the institutions and public policies themselves. That's our summary. Thank you very much, Jaime. Thank you very much, Roxana. I'm going to tell a little about what we talked about in room 1, which is management and risk analysis. We had a very interesting conversation, particularly around the use of the interferometry, satellite interferometry, a very powerful tool, as Miguel Angel Verdugo had mentioned. That was unthinkable. Well, I'm sorry, the noise you hear is the garbage truck that's going through outside my house. It's part of telework. Miguel Angel was saying that it was unthinkable some years ago. We were going to have 3 satellite images every 6 days. In the past, there was some other companies, and they had longer periods of time to provide the images, and what we do now is to have a daily revisit for a better monitoring. And there will be an open quote and close quote in real time. We need to see this type of things sometimes with a gap in time, delayed in time. It was also commented that although there's a lot of natural risk, the climate standards have been affected, rain, and things like that. There are some other type of risks associated to tailings that might produce any type of disaster. No long time ago in Peru, there was some news related to the disasters and the connection with tailings. And there's also a huge opportunity so that we can make some developments in this type of situation. That was more or less what we talked about in our room. Before we close, I would like to ask you if you can activate your cameras in order to have a group photo for today's session. Florencio, please, can you take the picture? Will you?
Inmediatamente, estoy esperando.
All right.
30 segundos a que prendan sus micrófonos.
I'm waiting 30 more seconds for you to open your cameras. I like to use this time before we close to kindly invite you for tomorrow. We'll continue with this workshop. Last session will be on Friday. Tomorrow's subject has to do with fires, how to monitor wildfires, how to analyze risk, a pretty interesting subject. We have seen that in Europe, wildfires have increased. In South America, the same has happened. So, once more, you are kindly invited to tomorrow's session. This is what I wanted to say. And once more, I'd like to thank your time, your attention for all speakers, attendees. Thank you very much. Please remember this is the second seminar out of the cycle of 5. In the end, in the late March and the early April, we hope to have one more cycle. Okay, take the picture. Florencio, please. You tell us when to smile. Florencio, your mic is off. Picture's been taken already. Okay, well, thank you very much for your time. And we hope to see you tomorrow and in the coming days. And above all, we do hope this can generate some connections, some networks we can bump into in different situations, generate new ideas, new projects, and we can learn from each other a little bit more about what satellite image are, Copernicus and the rest. Thank you very much and see you tomorrow. Thank you. Bye.
Chao, Miguel Ángel, un gustazo verte.